The following table of values corresponds to the function y equals f of x. Give tables of values for the functions y equals the absolute value of f of x and y equals f of the absolute value of x. Recall that the absolute value of a number is the number's distance from 0 on the number line. This will always be greater than or equal to 0. In order to determine points for y equals the absolute value of f of x if given points for y equals f of x, all x values will remain unchanged. All of the negative y values get changed to positive. Basically, you're taking the opposite of all negative y values. All points for which y is greater than or equal to 0 remain unchanged. These correspond to invariant points because they are unchanged in going from the original y equals f of x to the absolute value function. To determine points for y equals f of the absolute value of x, if you're given points for y equals f of x, all points with negative x values, simply change them to positive in order to determine the corresponding y values. All points for which x is greater than or equal to 0 remain unchanged. In this case, these correspond to the invariant points. Note that the resulting graph would be symmetric about the y-axis. Every point to the right of the y-axis could be reflected across the y-axis and correspond to a point on the graph. For our table of values, first of all, let's look at y equals the absolute value of f of x, keeping all of the x values the same. For x equals negative 3, y is 7 for f of x, so we keep it as y equals 7. For x equals negative 2, y is 0, so we keep it as 0. Looking though, if x equals negative 1, for f of x, y would have been negative 5. That means that for the absolute value of f of x, we make it positive 5. If x is 0, y for the original function is negative 2. For the absolute value function, it then becomes positive 2. If x is 1, y stays as positive 3. If x is 2, y remains positive 2. And for x equals 3, the y value changes from negative 4 to positive 4. Now looking at y equals f of the absolute value of x. For x equals negative 3, we have to look at f of 3. We're looking at the y value corresponding to an x value of 3. This corresponds to y equals negative 4. If x is negative 2, we're looking at the y value corresponding to x equals 2. This means that y would be 2. If x equals negative 1, we're looking at the y value corresponding to positive 1, which is equal to 3. All of the other points will be invariant, so they will have the same y value corresponding to these x values as the original function. If x is 0, y is negative 2. If x is 1, y is 3. If x is 2, y is 2. And if x is 3, y is negative 4.